Merci de m'avoir invité pour exposer nos...
Thank you for having invited me here today to talk about my work. So I'm going to talk about the new methods for cuttings that we're exploring just now in the horticultural field in order to modify the cultural itineraries. In 2014, we had many questions from the nurseries talking about production, talking about cuttings. For 15 years, we hadn't really seen any work in this field, so it's important to start exploring the various questions that we should ask. We arrived at a certain number of results and questions and even studies, which I'm going to present to you today fairly quickly. The sector is structured with seeding grounds, nurseries, and multiplicators for plants. And this is important. It's important because this is we try to understand our expectations from a young plant. Things didn't happen very easily, it has to be said. But what do we look for? We look for potential. We look for root development potential, architecture, growth potential, to see if they're capable to change itinerary for the new consumer as well today, in order to give rise to a product which is going to be attractive for the consumer. So we work on plants. We use cuttings, shrub cuttings. There are other horticultural fields where they use different means. Where they use seeds, but we use in plants we use the shrubbings. When we're using seed, it's because we haven't been able to take a correct cutting, so we tend to focus on cuttings. Bear in mind that for us, the young plant has an impact on the quality of the end product. For cross-cutting across other fields, I imagine, on the choice of culture we're going to use, the operational modes, and this can be expensive. We have to look at the organization of the plant, the production, and also cost price. The young plant is the starting point, so it's key. There's a current offer at the moment for young plants. We look at the various multiplicity in terms of cells, skin, the type of young plants. They're many and varied, but they're all based on the same system of multiplication, and that is cutting, woody cuttings or semi-woody cuttings. And we do this in autumn using production systems which are fairly low-tech, using very little complication. So we have to look at new systems for multiplication which allow us to optimize the methods, the breeding methods, production methods. So adapting quality, cost management, looking at evolution in sales periods, looking at the constant quality over the course of the year. And of course, we have to respond to logistic needs and manage the length of time of the cultivation period, and also be able, essentially, to adapt the range. So this is the work that we've developed in order to answer these questions. This was the first option. We chose to optimize a substrate shrub cutting. This is traditional. You go into the cells to begin your cuttings using industrial multiplication methods, these clods, and then using production of grassy heads rather than using the woody ones, using semi-herbaceous ones, grass-based heads, and also increasing the number of axes that were repotted in containers. Because usually we took one cutting, we created one plant, but there are other options available. We also tried to optimize new multiplication systems for the shrubberies using other example methods using aeroponics. And now we're talking about strengthening and hardening of the shrubs in these young plants and the cuttings taken from these young plants. What's the interest of taking these crop clods, if you like, as you can see in front of you from the shrubs? Well, as you can see from the photo, the two photos show us what? They show cuttings that were taken with clods. On the left, you've got an industrial cutting. On the right, you've got these cell plates that have given rise to this clod. These are cuttings that were taken at the same time, and 55 days later, you can see on the industrial side, well, you can see the result for yourselves on the left, still very good rooting, and on the on the other side, you can see it took 139 days using the substrate. So obviously these clods have a huge influence on the rooting, the root uptake of these plants. There's a great debate around the cost of this, but especially when you look at when you look at the advantages, I don't know if you can really ask these questions because obviously they're far better rooted in the first picture than the second. But of course, that depends on the time of year in which you take your cuttings and you carry out these multiplications. There are advantages when you do it in the spring, when you don't have any limiting factors like low temperatures that we would have in autumn. Well, then you have crop clods which are far better. You can diminish by 60% the length of time taken for the roots to really take. Now, another study that's been done is looking at the effect of these clods in the final quality of plants. So if you look at the end quality of the plants, what do we find? Well, in many samples, we've been able to compare young plants with these clods, as you've seen before, to others which are being planted in traditional cells. We say obviously by plates we mean ones that are in the substrate. And there are different types of crop growings or plant growing. And as you can see on the right here, in plant number 3, this is the type of product that we typically would want to have. You can see the plant is quite voluminous. The biomass is excellent. It's better compared to its neighbor anyway. This we consider as a high potential young plant, and there's a real optimization of the behavior in terms of irrigation as well in the management of this plant, and this can have a knock-on effect on the quality of the end product. It's obviously going to be much better. But what we can see clearly is that when we have a young plant which is full of potential, behind that you then have to have what? You have to have a production method which is going to allow the plant to express this potential, and it will allow us to use it to its maximum. No, that's a real advantage. Another question we have to discuss is about shifting the time of these cutting, working with more grass-based methods. For example, when you look, should we be taking head cuttings rather than the ones that are taken at the bottom? This is the second one is one we take from the middle of the stem. Normally, it's two leaves gives you 2 buds. So that means we can have 2 different branching patterns. When you use head cuts, you have a stem which is more contracted, and you have more leaf folds. You're going to have a higher number of branches on this cutting. Not everything grows at the same speed. The root uptake is not the same for each. If you put that into a multiplication plate, you get very heterogeneous batches. If you look at the head cuttings, you have to really manage them more closely. So here, this is lavender. We've got PMRs that we're working on. We take several cuttings. We can take them from different production methods. We have plants which are very small but have very high potential for growth. And we prefer to do that now rather than taking young plants or plants which are slightly older and slightly bigger, but they don't really have any potential because they have actually aged too early. So with these systems, and we're going to work across several species using this, you look at the different cuttings you can take. You can see you get plants which grow with a great deal of branching fairly quickly. In the course of several months, you can have a plant which can be sold. We developed this in bigger container plants eventually, so we're scaling up. This is a technique as well that we use. You can use several cuttings to have one plant rather than just having one single cutting, which you're going to have to trim on several occasions and then repot. So the idea is then to use several cuttings in one container or one pot in order to speed up the growing section of their life. So you can actually restake cuttings as well to help them grow in a more appropriate fashion. And when you do that, this is what we get. We get growing cycles which are quite short, so this leads to important gains, advantages for the commercial sector. We've experimented on a certain number of species. We've obtained plants which have a great branching session, as you can see at the bases. It's important for us, it's important, aesthetically speaking, obviously, people want to see a flowery, bushy plant.
So we also have developed tools where we can restake several cuttings in one clod, so that it makes the repotting process easier. Because they only have to repot 3 times less to prick out 3 times less. So it's easier to have young plants that have 3 cuttings to repot each time. It's what you see on the right-hand side. It's small, but with great potential. Then we tried to bring together all these techniques in one multiplication system to really optimize all the production methods. So it starts with herbaceous cuttings, multiplication in warmer phases rather than autumn, with having head cuttings from the mother plants, with restaking with more than one cutting per clod. If we use all that together, it's very interesting. The top line is the traditional version. It takes quite a while for the multiplication. Then you have the repotting from rooted cuttings in pre-containers or mini pots, if you will. So that's the pre-container, which is in yellow. And then you restake them again in their final container for their final breeding phase. So if you want a 7-liter container, it can take over 2 years, 2 years and a half. What we're offering is to have a much shorter multiplication phase and to restake directly in the final container. And we started doing this on several taxons, about 20 actually, with pretty interesting results so far, because for Choisia, after 16 or 17 months, instead of 2 years and a half, we have plants that are ready to be sold, with populations that are very homogeneous, that reflect the potential of this multiplication technique. Another example on this plant. We start with a very small plant. In the middle, you have a picture which looks really leafless, if you will, but after less than a year, this is what you get. So less than a year between the cutting and the final repotting, you have something with a lot of branches, with a lot of leaves, something that looks great and is ready to be sold, very attractive for consumers. And so it takes 14 months to get there, whereas conventional systems, traditional systems, would take about 30 months. So this process has been implemented on several species on which it does work well. Some species grow more slowly, so you gain less time. But some species are actually not really favorable to this kind of multiplication. This is why we tried to understand why those species did not respond well to this technique, and we tried to develop new techniques a technique that hasn't been used yet, except in a few US and India labs on bushes in order to multiply bushes. One of the reasons why traditional cutting does not work on these species is that rhizogenesis, so the growing of roots, is depending on the level of oxygen available. And in substrates with fog, there's a problem of an anoxia because there's too much water for the cuttings, and this process is difficult to regulate and optimize. So thinking about it, we started thinking we need to get rid of this limitation. This is why we looked into aeroponia. This is only experimental. It's not industrial level yet. This is what it looks like. You put the cuttings on plates, on trays, and they're not in substrate, they're in the air. And they are sprayed from the bottom thanks to a spraying system. And we tried that on lavender, on Photinia, because these are species that we know respond differently to cuttings. And so the results were very interesting. For instance, after 3 or 4 days, we did the cuttings, and after 15 days, we can restake. For the photinias, that are a bit slower, you need to use oxine, because even with those systems, there are limitations. The cuttings actually clot, and they don't grow roots that much. So if we add oxine, to the concentration, depending on the concentration and the type of oxine we use, the results can be very interesting with percentages that can be pretty high. And the idea behind having such a developed root system is that when you restake the plant, each root is a source of absorption of minerals, so it makes the plants more vigorous. And it's very important for photinias, where with the traditional cutting methods, there are always issues with branching. There aren't even enough branch growth, so it makes the culture longer to have them look okay. Whereas here, the rooting system is so fast and strong that the potential for branching afterwards because of the stronger plant is multiplied. So it's very interesting. So, the hardening of mother plants and young plants. This is a topic we have been working on for about 2 years, only 2 years. The idea is to work on the IRHS in Angers. What we're developing with them is that hardening mother plants make it possible to have cuttings that are more tolerant to drought, basically. So it was demonstrated on a bush, and the idea was to see if it was possible on shrubs. So we harden them, we make them stronger through hydric stress. We have computer-based or computer-assisted spraying, and so we control the restriction that the plant undergoes. So our cuttings are either in hydric comfort or hydric stress, and we compare the results on the culture. The effect of hydric stress is very important, of course, as it would happen in the culture when you restake in containers. It was explained previously, the effect of hydric restriction. You all know about it. It reduces the quantity of vegetation, the leaf surface. So it reduces the volume as well as the need for water. So these are ongoing studies. The effect so far of hydric stress on the capacity to descendants to adapt to drought, well, of course, it's not fully assessed yet, but we feel that the plants are better adapted to drought. They resist more to longer interruptions in spraying, for instance. But what happens in containers is that the volume of substrate is restricted and the water reserve is restricted. So after a while, we have to give them water again. When the reserve is finished, whether the plant is adapted to restriction or not, when there's no more water, there's no more water. It's not like in nature where they would be able to go and find some more. So to reduce environmental impacts, we are working in biodegradable containers, so no more plastic pots. So plants are bred, basically, are growing in those biodegradable containers, and so the biodegradable containers is planted at the same time as the young plant. It raises a few issues in terms of how does this container degrades. How can the roots keep growing without it stopping it? There are a lot of questions when you use them. So thank you for your attention. Thank you, Laurent. We're going to have some questions from the audience. I can't see if people are raising their hands to get the mic. But I have a first question for the time for the mic to reach people. On shrubs that are usually planted for a certain amount of time, how do you follow up these plants after they leave the nursery? Is it in experimental sites? Do you have a network of users that can help you doing a follow-up for a more long-term assessment? Those works are taking place in the test stations. So there are producers that are starting to include those results in their processes. And then the plant, when the user will put it in soil, it does not change its capacities to implement. It's not because you've accelerated the root growing process at the breeding stage that it will reduce its capacity to adapt to the soil. There's no modification there. So its final use will not be impacted. And its adaptation, when it arrives in a garden, for instance, will not be impacted. Magali Pellissier from ITEPMAI. Regarding the small clods that you're using, are they pre-molded? We can see that the roots clog together quite quickly. So how do you make sure that the roots grow properly and colonize the pot completely, or do they stay really clogged around the clod? Well, there's a need for coordination between roots growing and plant growing. We don't want to have clogs in the growth. A lot of producers spend too much time. Well, they wait for too long until repotting, and that's not good for the root growth. But in pots, it's pretty optimized, and the root growth is not really hindered. In soil, in difficult soils, it would be different. But if we want to shorten, because one of our objectives in the process is to not leave young plants in their tray for too long. So as soon as the roots are optimum, that you can see them on the surface of the clod, that's the right time to repot them. And in terms of implantation speed and planification. We need to really repot them at the right moment. If you leave the roots grow and grow and grow and clog, it's not great. We need to coordinate all the phases between multiplication and breeding. And have you ever tested planting those clods in the ground directly? Oh, it would be possible, because this technique of clod multiplication, in the station we work a lot with this method. And when people would actually use direct seeding or sowing, now with the disappearance of chemical weeding, a lot of people use even smaller clods and put them directly in the soil. It's for cabbage, it's very much the case. And it makes it possible to have mechanical weeding, whereas with direct sowing, it's much more difficult. Or you can also put your seed in a clod. I hope I've answered your question. Yes, you have. Good morning. Denis Vernet. I produce maps. In terms of aeroponia systems, I think it's very interesting. At a larger scale, would it be interesting in terms of savings for water, because you don't sprinkle, you spray, for substrate as well? Yeah, I didn't say it in my presentation. We have a project which is starting with the ETEPMAI to develop an industrial tool where we're including the production of cuttings with that technique. The idea is to have a machine where we can produce cuttings in a large quantity, taking into account the laying out of the cuttings and the harvest time as well, to see if it is industrially viable. And what's interesting in this system is that it really improves the sanitation status, the health status. We never had to use a fungicide on our cultures in aeroponia because the aerial parts are in a dry environment, so they can't develop fungi. So in order to reduce the transpiration of the cuttings, we have a plastic casing, but there's no spraying in the casing. So they don't lose all their humidity, but we don't add any extra humidity. So in terms of sanitation, for multiplication, it's much better. In the traditional system, with fogging, for instance, the environments are really promoting diseases. Here it's a short circuit. We have water pipes. We don't fertilize because fertilizing sprays is going against rhizogenesis. But what's very important is the temperature of the water you spray. It's interesting to make it warmer. But we don't heat the entire tunnel. We only heat the water. We warm the water. So it's more economical. And we're studying with the ETEPMAI to see if it's industrially viable. I hope I've answered your question. Thank you, Laurent. In order to keep our schedule, we're going to have to stop. Yes, he deserves a round of applause. And so now